Okay, sir.
Everyone. Now, uh, we are about to start some basic concepts, okay, of pre-stress concrete. So, first concept is pre-stressing transforms concrete to elastic material. This is your concept number one. Okay, pre-stressing transforms your concrete to elastic material. Okay, that means what? That we are considering our concrete as an elastic material during the pre-stressing portion and the calculation of the pre-stress stresses and analysis. Okay, so let us consider a longitudinal section. Okay, for this longitudinal section we have our stress diagrams. So one is our external stress diagram. Okay, external stress diagram, top में compression, bottom के अंदर tension, and this stress diagram from M by Z. Okay, M is the external moment and Z is the section modulus. What do we say? That we apply a concentric load at the center, which is trying to compress this particular member. Okay, at the center, I am applying a tendon over here, and that tendon is first stretched outward. The tendon is stretched outward and anchored at the two ends and then cut and released. Tendon is cut and released at that, try to come towards its original length, and in that process it will induce two inward forces, okay, of magnitude F and F from both the sides at the center. Because of these forces, there is going to be a direct stress which is going to be applied on the cross section. Why I'm saying direct stress? Because I am applying this particular tendon or this particular force at the center of the cross section. So if I'm applying at the center of cross section, what do I get? I get a direct compressive stress. Okay. So suppose that because of this, the direct compressive stress that I'm going to get is going to be totally compressive. Okay, and that we are going to get, let it be P, the load that we apply in pre-stress concrete. The pre-stressing load that we apply, we try to denote it using the letter P. So the direct stress that will be coming on the cross section is going to be P by A. Okay, the combination of these two, see, I know that few of the students have taken pre-stress concrete as their elective, so they might be feeling that this particular session is very redundant. But these are some different notes. Probably you might find a thing or two interesting or something with a different perspective to learn and understand over here. Okay, Also, if you have any queries or any suggestions or anything regarding what I have taught, you can anytime share, comment, or you can unmute and speak as well. Okay. So, combination of the external load and the pre-stress load is going to give us the equivalent load. Okay. So, equivalent load can be of different types, but for our sake of understanding over purposes, we are saying कि compression और ऐड होके बहुत ज़्यादा compression हो जाएगा टॉप फाइबर के ऊपर, और नीचे का टेंशन और compression counteract करेगा और नीचे थोड़ा सा ज़रा सा compression बचेगा. Okay, so this is your final effective force or stress diagram for the cross section. Okay, so in this current scenario, if we see the concrete member is subjected to two forces. Okay, first force is the external force, and second force that it is subjected to is first force external load including its self-weight. External load including its self-weight. That is the one type of load which is acting, and second type of load which is acting on the concrete member is pre-stress force. Okay, now depending on the location and the position of this particular pre-stressing force, it is possible to get different pre-stressing diagrams. So by making the pre-stressing cable eccentric, we can get a triangle kind of this moment kind of a diagram over here. Okay, by making the shape of the cable different, we can get this diagram as a zero force diagram. Okay, by making the profile of the cable so as to match the bending moment diagram, we can try and get the equivalent diagram as a zero force diagram or zero tension diagram. Okay, such kind of diagrams are possible. Okay, so now let us start solving a few examples. Okay, now basically for example part, I'm not going to solve any examples over here. I'm going to basically show you that what is concentric, what are the formulas for concentric and all those things, and then you are going to receive a tutorial in which we are going to have some numerical values which are assigned to this particular problems, and then we are going to solve it. Okay, so example 1 is concentric pre-stressing. Okay, what do we mean pre-stressing? As the earlier example suggested, suppose this is your member, and for this particular member simply supported at both the ends. Okay, simply supported means the end moment at the both the ends, the end moment is going to be 0, so it is not restricted for any sort of rotation at the ends. Now at the center, this is the centroidal axis, and through the centroidal axis we are passing a cable which is going to apply a pre-stressing force. Okay, let the pre-stressing force which is acting be P. Okay, which is acting at both the ends. Okay, and obviously वो जो amount of force रहेगा वो दोनों ही side के ऊपर P ही रहेगा. Okay, it cannot be that one side पे इसका जो force का value है वो P है और दूसरे side पे जो value है वो P1 P2 रहेगा. There is a scenario in which that is possible. Going to discuss in the losses. But for our scenario, try to understand that जब हम केबल को कट करते हैं तो हम मानते हैं कि जो केबल है वो दोनों साइड से एक ही केबल है, सिंगल है, जुड़ा हुआ है. सो इट इज गोइंग टू हैव सेम लोड और सेम रिएक्शंस एट बोथ द एंड्स. ओके, देन let us make a cross section. Okay, this is your cross section. In the cross section, what I am telling you is that this is the duct or this is the position at which I am applying the P. Okay, so at the center, at the centroidal axis, we are applying this. Okay, so the stress diagram that we are going to get, the stress diagrams that we are going to get is first is we are going to get the pre-stressing force, because the pre-stressing force is acting at the center and is causing only the direct stresses. Direct stress is evenly distributed along the cross section. The direct stress is evenly distributed along the cross section, so that direct stress value will be given by P, which is the magnitude of the force divided by the total cross sectional area. Okay, this is the amount of pre-stress which is acting on the section, plus the other stress. Which is the other stress? The stress because of the external loading plus self weight. The stress because of the external loading और self weight. अब ये कहाँ से आता है और ये कहाँ पे है? Just try to understand. जो external loading है, that is acting over here like a UDL. Okay, and this W is equals to your plus your dead load. Okay, सो WL प्लस WS मिला के जो आपका टोटल UDL बनेगा बीम के ऊपर, वो UDL जो इसके ऊपर बेंडिंग क्रिएट करेगा, वो बेंडिंग की वजह से जो स्ट्रेस आएगा क्रॉस सेक्शन के ऊपर, दैट स्ट्रेस वी हैव टू डिनोट ओवर हियर. सो वी आर मेकिंग अ जनरल डायग्राम फॉर दैट जनरल फोर्स स्ट्रेस ब्लॉक. Okay, so because it is a sagging bending moment, the top fiber is going to feel compression and the bottom fiber is going to feel tension. So top is going to be M into the distance from the center to the top fiber. Okay, MC by I, and similarly the bottom will also be M to the distance to that bottom fiber divided by I. Okay, in our case we always say that okay My by I, but अगर ये symmetrical section है तो y1 और y2 का वैल्यू सेम रहेगा. So same वैल्यू होने की वजह से we always say that it is going to be M by Z. Okay, so we can say that this equation can be written as an equivalence for a symmetrical. We are considering a symmetrical section. See, if the section is not symmetrical, then you have to go for My by I. But if the section is symmetrical, you can go for M by Z. Or you have to say that for top portion you are going to have M by ZT, and for bottom portion you are going to have M by ZB. Okay, Z for the bottom portion. This gives us a combination of stress that will result into a diagram that will look something like this. Now what has happened over here is you have your P by A stresses which are acting over here, and because this is compression and this is compression and both the stresses are having the same sense, so P by A plus M by ZT, and over here because this is creating compression and this is creating tension in the bottom fiber, the sense of this stress and sense of this stress are completely different or opposite to one another. So over here this is going to be P by A minus M by ZB. Okay, so the resultant stress, or if we say, if you want to write a formula for stress, okay, so stress is represented by small f, that is equals to P by A plus minus. Plus is for the top fiber, minus is for bottom fiber. Always remember, we are going to, in multiple of the formulas, we are going to use such kind of signs where there are going to be plus minus, minus plus, plus minus, like that. So always remember, the top signs are for top fiber, the bottom signs are for the bottom fiber. Okay, plus minus M by Z. Okay, going to be this one, this formula, and for bottom fiber it is going to be this formula. We are defining over here as a common Z value, but actually it is not a common Z value. Okay, for top fiber it is going to be ZT, for bottom fiber it is going to be ZB. Try to understand, if there is a T section like this, okay, and for T section you are trying to determine or analyze the stresses, what will happen over here? Your YT value and YB value are going to be different. Okay, because of that your ZT value and ZB values are also going to be different. Okay, so try to understand. So this is your very basic problem in which we are considering it as a concentric part. Okay, now let us see another example. If the cable is placed eccentrically, if the cable is placed eccentrically, with respect to the centroid, comma, additional moments introduced. Additional moments introduced in the section. Now what does this mean? Try to understand what does this mean. Okay, so let us make the same longitudinal cross section of the diagram. Okay, provide the same type of support. Okay, so it is hinged at both the ends, so there is moment releases at both the ends. So at the end support, the moment, because of the external, is going to be zero. Okay, because of the external loads, the moment is going to be zero. Now what do we see over here? This is our centroidal axis, and now we are not applying the cable at the center, we are applying the cable at an eccentricity E from the center at the bottom. Okay, so at a distance E from the center towards the bottom side, we are going to apply the pre-stressing cable, same pre-stressing cable, having a pre-stressing force P inside the cable. How do we get this pre-stressing force? हम लोग केबल को stretch करते हैं. स्ट्रेच करते हैं तो उसके अंदर स्ट्रेन आता है, उसमें डिफॉर्मेशन होता है और उसके अंदर वो स्ट्रेस स्टोर हो जाता है। फिर जब हम लोग उस केबल को एक साइड पे टाई करते हैं और दूसरे साइड पे भी उसको खींच के रख के एंकर करते हैं एंड देन वी ट्राई टू कट द केबल, सो दैट मच अमाउंट ऑफ स्ट्रेस गेट्स ट्रांसफर टू द कंक्रीट एज द रिएक्शन एट बोथ द साइड्स. Okay, so let us make a diagram over here of the cross section as well, so as to represent in the form of cross section and you will be in a position to understand. Okay, suppose this is the centroidal axis. At the centroidal axis over here at an eccentricity E. At this location, we are applying the cable, pre-stressing cable. Okay, and that cable is applying a load P on both the sides. Okay, now what will be the effect if we try to provide this cable eccentrically? अगर हम लोग इसेंट्रिकली लोड को डालते हैं तो आपने कॉलम के ऐसे प्रॉब्लम्स देखे होंगे जिसके अंदर हम लोग अगर कॉलम के ऊपर जो लोड है उसको सेंटर की जगह पे अगर इसेंट्रिसिटी पे डालते हैं तो क्या होता है? Can anyone tell me that what will happen if the load is applied eccentrically?
Bending moment.
Huh?
Bending.
There is going to be a moment. Okay.
Yes.
Moment produced by what? The external load or the pre-stressing load? Moment will be produced by what? External load or the pre-stressing load?
Pre-stressing load.
Pre-stressing load. Because now the pre-stressing force is not acting at the center. As the pre-stressing force is eccentric, it is going to create a. Okay. Now that try to understand the rotational direction which are happening over here. Because of this pre-stressing load, if you see, it is trying to rotate the cross section in this direction. Okay. So the moment produced or the sense of rotation that is produced by this particular, what we can, this is the somewhat direction of deformation which is produced because of this particular pre-stressing force or pre-stressing moment. Okay, which is a sense of hogging. Okay, and the external load which were present that produced sagging. Okay, so eccentricity in our current scenario we have assumed in such a sense that it is producing a bending moment which is opposite to the sense of, which is opposite in sense to the bending moment coming from the external load. Okay, so first type of stress which is going to come because of the pre-stressing is the direct stress. Even though it is at an eccentricity, the direct stress will be caused by this particular pre-stressing force. Okay, and the magnitude of this direct stress is going to be P by A. Okay, plus there is going to be a a moment which is produced by this particular load P at an eccentricity, which is going to be P into eccentricity. This is the moment. Okay, this is the moment which is produced. Okay, and this is going to be tension at the top opposite to the direction of this. Okay, and compression at the bottom. So this is moment multiplied by the distance y divided by I. Okay, yt and yt. So you can say P by zt. Okay, moment divided by zt. Similarly at the bottom also you have P into E, P into E into YB divided by I, or you can say P by ZB. Okay, now these are just because of the pre-stressing. ये जो दो स्ट्रेस डायग्राम अभी आपके सामने दिख रही है, ये दोनों स्ट्रेस डायग्राम, these are only because of the pre-stressing force, and one extra diagram is added because the pre-stressing load was applied at an eccentricity. ठीक है, अब जो हम लोग लिखेंगे वो हमारा यूजुअल कंपोनेंट है. ठीक है, कौन सा है हमारा यूजुअल कंपोनेंट? बिकॉज ऑफ द एक्सटर्नल मोमेंट. ओके, so because of the external movement, compression at the top, tension at the bottom. So moment into y divided by I yt, that is equals to m by zt, and moment into y by yi divided by I, that is equals to m divided by zv. So the final diagram which we are going to get because of this, see every time we are making such kind of trapezoidal diagram, but it is not necessary कि हर बार ऐसा trapezoid ही बनेगा, ठीक है? कभी कभी अलग अलग शेप आते हैं, जब एनालाइज करेंगे ना यू विल अंडरस्टैंड दैट देयर आर डिफरेंट डिफरेंट शेप्स. जस्ट फॉर योर सेक ऑफ अंडरस्टैंडिंग हम लोग यहाँ पे ऐसे अलग अलग डायग्राम बना रहे हैं. ओके, सो डोंट वरी. सम ऑफ द टाइम्स दिस डायग्राम कैन बी अपोजिट ट्रेपेजॉइड आल्सो. बॉटम फाइबर में ज्यादा कंप्रेशन आ गया, टॉप फाइबर के अंदर टेंशन आ गया, क्योंकि प्री स्ट्रेसिंग मोमेंट ही बहुत ज्यादा था. प्री स्ट्रेसिंग मोमेंट हमारे एक्सपेक्टेड एक्सटर्नल मोमेंट से कहीं ज्यादा निकला. दैट कैन ऑल्सो हैपन. Okay, because there are different load combinations as well. Some of the times it is pre-stressing plus dead load only. Some of the times it is pre-stressing plus live load. Okay, and some of the times it is just the pre-stressing load when the member is kept at the ground. जमीन के ऊपर हुआ है, तो ऐसे टाइम के ऊपर तो उसका डेड लोड भी है, उसमें बेंडिंग मोमेंट क्रिएट नहीं कर रहा है, सिर्फ प्री-स्ट्रेसिंग फोर्स ही है. ओके, so such kind of scenarios are also there. So we have to consider multiple scenarios. Some scenario is there when we are carrying a member of pre-stressing, जिसके अंदर उसकी जो support condition है that is going to be completely different than the support condition for which it is going to perform for its complete life. So वो support condition और double overhang वाली जो support condition है वो भी दोनों अलग अलग हो सकते हैं. ये सारे अलग अलग फैक्टर्स के लिए हमें अपने कंसिडरेशंस लेके फिर मेंबर को डिज़ाइन करना पड़ता है, ताकि मेंबर उसकी कास्टिंग से लेके कि उसके लोकेशन पे पहुंचने और सर्विस स्टेज तक, इनमें से किसी भी स्टेज के अंदर वो स्ट्रक्चर या वो मेंबर जो है वो फेल नहीं होना चाहिए. ओके, सो द फाइनल डायग्राम विच आई एम गोइंग टू गेट ओवर हियर इज गोइंग टू हैव एन इक्वेशन विच इज फर्स्टली P by A. इसके अंदर से हमारा जो मोमेंट है, बिकॉज पूरा टॉप से बॉटम तक जो है दैट इज गोइंग टू बी कंप्रेशन, बट बिकॉज ऑफ द प्री स्ट्रेसिंग द टॉप फाइबर इज फीलिंग टेंशन, सो माइनस P by ZT, and because of the external load the top fiber is feeling compression. Do you agree with me?
Yes, sir.
Okay, so the formula is going to be like this: P by A minus P by ZT plus M by ZT. Okay, this P by A, P by ZT, M by ZT, ये सब चीज़ें क्या हैं? ये सब यही स्ट्रेस डायग्राम्स है जो आपके सामने मैंने बनाए. स्ट्रेस डायग्राम्स किसके हैं? हर अलग अलग लोड की वजह से क्रॉस सेक्शन पे आने वाले स्ट्रेसेस हैं. ठीक है, सो ये जो फॉर्मूला हम प्री स्ट्रेसिंग के लिए यूज़ करते हैं, ये कोई ऐसा बहुत डेंजरसली डिराइव्ड कोई फॉर्मूला है, ऐसा कुछ भी नहीं है. बहुत ही सिंपल और बहुत ही बेसिक कंसेप्ट से बना हुआ फॉर्मूला है. ओके, सो ओवर हियर दिस इज P by A, then compression plus compression for the pre-stressing part, so plus P by ZB, and then tension at the what we can say tension at the external loading. So because of the external loading there is going to be tension, so minus M by ZB. Okay, so these are how your final stress diagrams are going to be. So these loads, these are your pre-stress, and this is your external stress. Okay, so the final formula for stress, okay, this is your small f for stress is equal to P by A minus plus P by Z plus minus M by Z. Okay, I hope you understand this plus minus signatures. Okay, ये जो साइंस हम लोग यहाँ पे यूज कर रहे हैं प्लस माइनस माइनस प्लस, इसका मतलब आपको शायद समझ में आए. टॉप फाइबर के लिए P by A माइनस PE by Z प्लस M by Z. बॉटम फाइबर के लिए P by A प्लस PE by Z माइनस M by Z. बराबर है ना मैडम?
नहीं, मैं तो कलर आप अच्छे यूज करो देगा। आपको सबसे ज्यादा कैसे लिखता है? मेरा बहुत पतला पतला लिखता है।
इसमें सिलेक्ट कर सकते हैं ना आप कितना आपको चाहिए। Okay, so let us move to next example, example 3. Now, our third example, we are going to see a numerical related to the application of what we have learned right now. Okay, so you can write the question with me. A pre-stressed concrete a pre-stressed concrete rectangular beam of size 500 by 700 mm, 500 by 700 mm has a span of 8 meter. It is loaded by uniform load of 40 kilonewton per meter, including self-weight, including self-weight. The cable are located the cable are located at eccentricity of 120 mm at eccentricity of 120 mm and and produce force of 1300 kilonewton 1300 kilonewton. Calculate the extreme fiber stresses. Okay, so let us represent everything in the diagrammatic format. This is going to be your question. There won't be any diagram or anything that will be provided to you. Okay, so we have to make the diagram, we have to make everything presentable, okay, so that we can solve this particular problem. Okay, so at a distance of 120 mm, we have provided a cable having a load equal to 1300 kilonewton. The cross section is going to look like this. Okay. This is your center. This is 500 This is depth is 700. And the eccentricity at which we are applying is 120. Okay, so this is your cross section. The total span of this beam is 8 meter, and the UDL or uniform load which is acting on the beam is 40 kilonewton per meter. This is including the self weight, so no need to calculate the self weight for this particular beam. Okay, so now for this, what do we need to calculate and what are the things that are required? मुझे निकालना है f का वैल्यू. Okay, I have to calculate the value of ft and fb, which is the top fiber stress and bottom fiber stress. अगर ये मुझे यूज करना है तो मुझे फॉर्मूला है p by a प्लस pe by z प्लस m by z, जो भी रहेगा प्लस या माइनस, तो माइनस रहेगा नीचे, प्लस और माइनस रहेगा ना. इसमें से p का वैल्यू मेरे पास में है, इसेंट्रिसिटी का वैल्यू मेरे पास में है, एरिया आई डोंट नो, z आई डोंट नो, मोमेंट आई डोंट नो. दीज आर द वैल्यूज आई नीड टू कैलकुलेट. I hope you understand. So before proceeding to the formula, it is necessary that we determine all the essential components of the formula so that we can substitute those values into the equation and we can get our final answer. Okay. So can you give me the area of cross section? Area is equals to then can you give me the value of z? Now this is a symmetrical section about the axis, so zt is going to be zb, is going to be how much? Can you give me the answer? Faisal is saying 40.83 into 10 raised to 6. Is it correct? Everybody is getting the same answer. Anyone else who can confirm? Okay. Okay. So let us take that value, 40.83 into 10 raised to 6. 40.83 into 10 raised to 6 mm cube. Then we require the value of moment. What is the moment? External moment which is acting? 40. Fully supported beam, it is going to be WL square by 8. So W is 40 into 8 square divided by 8, that is equals to 320 kilonewton meter. Okay, or in terms of mm, it is going to be 320 into 10 raised to 6 Newton mm. Okay, the value of other essentials, we'll just note it down over here. Eccentricity is equals to 120 mm and force is equals to 1300 kilonewton. Okay. Sorry, for this particular problem we are considering this is 1300, but it is 1500. Some mistake has been done from my side instead of writing, so consider this as 1500 1500 so Now at different locations, there is going to be different stress positions. Okay, just try to understand. This is your beam. Okay, this is your beam. This is your support condition, UDL, which is acting. So if because of this you try to make the bending moment diagram, the bending moment diagram is going to look something like this. Okay, at the center it is going to be WL square by 8, but at support the moment is going to be 0 because of the external moment. Okay, now what about the P into E? P into E का जो moment यहाँ पे cause हो रहा है वो कैसा moment रहेगा? Try to understand. This is okay at an eccentricity. P का वैल्यू जो है, ठीक है, at every cross section the distance of P with respect to E remains same. मतलब आपके जो सेंट्रोइडल एक्सिस है उससे जो आपका लाइन है, लाइन ऑफ एक्शन ऑफ फोर्स, वो सेम डिस्टेंस पे है, सेम एसेंट्रिसिटी पे है. मतलब हर क्रॉस सेक्शन के ऊपर जो मोमेंट है वो मोमेंट जो है आपका सेम रहेगा. ओके, सपोज दिस इज पॉजिटिव बेंडिंग मोमेंट, सो दिस इज गोइंग टू बी नेगेटिव बेंडिंग मोमेंट. ओके, सो सपोर्ट के ऊपर भी ये P इंटू ई रहेगा और ये सपोर्ट के ऊपर भी P इंटू ई रहेगा, सेंटर में भी ये P इंटू ई ही रहेगा. Are you getting it? So it is going to be a uniformly distributed kind of a moment at every cross section. Okay. So this is because of the external. This is going to be because of the pre-stress. ओके, दो बेंडिंग मोमेंट डायग्राम्स में आपको समझाने की कोशिश कर रहा हूँ. सो दो कंडीशंस ऐसी हैं एक्सट्रीम वाली, जैसे कि एक सपोर्ट है, तो सपोर्ट के ऊपर एक्सटर्नल मोमेंट 0 है और प्री स्ट्रेसिंग मोमेंट अपने मैक्स पे है. एंड सिमिलरली एट द सेंटर एक्सटर्नल मोमेंट जो है वो मैक्सिमम पे है और प्री स्ट्रेसिंग तो क्योंकि वो कॉमन ही है तो उस तरीके से है. सो व्हाट विल बी इफेक्ट एट द सपोर्ट एंड व्हाट विल बी इफेक्ट एट द सेंटर, वी आर गोइंग टू सी. ओके, so first let us calculate at midspan. Midspan F is equals to P by A minus plus P by Z plus minus M by Z. Is equals to 1500 into 10 raised to 3 divided by area is 350,000 minus plus 1500 into 10 multiplied by 120 divided by 40.83 into 10 raised to 6 plus minus external moment is 320 into 10 raised to 6 divided by 40.83 into 10 raised to 6 Z value. That is equals to. Can you give me the value for the first component, first part over here? 1500 into 10 raised to 3 divided by 350. 4.2857. Is everyone getting the same answer? What about the second component? Second part, the pre-stressing moment stress. The stress, the moment stress because of the pre-stress. That part, second part. Can you give me the value? It is not possible what you are saying. 90 into 10 raised to 6 is not possible. Please check. It is 1500 into 10 raised to 3 multiplied by 120 divided by 40.83. Four point 4085. Is everyone getting the same answer? Please check. Okay, so now we have the values for all the three components. We can write it for FT and for FB, and we can get the values for top fiber and bottom fiber. For top fiber, it is going to be 4.28, 4.4085 plus 7.837. What that will give you a certain value. And then for the bottom fiber, we have 4.2857 plus 4.4085 minus 7.837. So for top fiber, okay, for top we are getting 7.137. Okay, for top we are getting 7.137, 7.7137. Okay, sorry. And for bottom fiber, we are getting the value of 0.8577. Now this answer 0.8577, are you getting positive or negative? I hope it is positive because these are 4.2 and 4.4 are 8.6 itself. So the answer will be coming positive. So this is compression and this is also compression. So the stress diagram for the support is going to look like this. Okay, top fiber is going to be 7.7137 MPa and bottom fiber is going to be 0.8577 MPa. Okay, completely in compression. Okay, so this is for the top fiber. Similarly, I would like you to calculate for the bottom fiber. Sorry, not bottom fiber, at support. We have calculated for the mid span. This was for the mid span. I want you to calculate for support. What will happen at support? The moment will now be zero. Everything else will remain same. Okay. So now what will happen? The complete formula that you wrote P by A minus plus P by Z plus minus M by Z. This formula is going to be cancelled out. Based on that, calculate the value of FT and FB. Okay. I give you 2 minutes to calculate that. Hamza is saying that sir not support mid span, but what we actually calculated right now was for the mid span. Yes, for the mid span. So calculations for mid span are already done. Okay, and this final stress amount of stress that we calculated over here, this is for the mid span part. Okay, at mid span the cross section is in this stress condition because of the pre-stress as well as the external load. And now at the support we are trying to calculate. So it is going to be considerably very simple. We have already calculated most of the values over here: 4.2857, 4.4085. Okay, so first is going to be minus, then is going to be plus 4.2857 plus 4.4085. What is the answer we are going to get? Can you give me the amounts of stresses? For the first part, we are going to get negative. For second, we are going to get positive. For the first part, for the top stress, the amount is going to be minus 1.228 as suggested by Ananya Sawant. And for the bottom part, uh, for the bottom, it is going to be 8.69 as suggested by Hamza. So 8.69 MPa. So see, always your answer is not finished until and unless you make the stress diagram. Okay, so please always make the stress diagram. Okay, so suppose we are showing this direction is negative, this direction is positive, so show it in that way. Or you can say this is compression and this is tension, like that. The diagrams can be exaggerated also, but try to make it proportional. Okay. At the top fiber, MPa at the bottom fiber. Okay, so top fiber and bottom fiber. Is it clear? Is it clear to you how we calculated these stresses? Everyone, is it clear to you how we solved this particular problem and calculated the stresses? This is a very basic thing to do. And I know half of your class has took the pre-stress concrete as your elective. So I don't need to worry about those half people. But the remaining half who are not taken the pre-stress concrete. Are you able to understand this? This is a one type of problem that can be asked to analyze this particular structure, and this is a very basic problem. Obviously in the tutorial part we are going to discuss in detail with much more different types of problems. Okay, now let us discuss other type of pre-stressing that can happen. Okay, so we saw eccentric. Let us see parabolic pre-stressing. So what will happen with parabolic pre-stressing? Okay, so for parabolic pre-stressing, I am taking a concentric at support and eccentric at midspan, that kind of a situation. So your pre-stressing cable is passing through the concrete, having an eccentricity at the center and is concentric at support. What does this mean? That means at support, P by A is going to be there, but P, because the eccentricity at support is 0, okay? So the moment produced by the force at the support is going to be 0. As well as if you see, if this is a simply supported condition, if this beam is simply supported in condition, then the external moment is also going to be 0. Okay, this we are talking at support. So the only stress that is left at support is going to be P by A. But try to understand what happens at midspan. What happens at midspan? At midspan, if you see, there is going to be P by A. Obviously, there is always P by A. P by A is always going to be there. Then there is going to be PE by Z because there is eccentricity at the midspan. So PE by Z. And then plus minus. There is going to be moment also over here. But if you see this PE by Z and M by Z are having opposite signs to one another. So these two stresses are opposite in their nature. So they are going to mostly nullify one another and very residual amount of stress will be left. So majority the amount of stress which is going to be left is going to be P by A and whatever is the difference of these two, which is going to create a much more, what we can say, safer condition for our beam, or much more we can say the stresses for which we are going to design are going to be under the range of design. ओके क्योंकि अगर आपका कंक्रीट जो है वो 10 MPa के अंदर रहने वाला है तो आपको 10 MPa के स्ट्रेंथ का ही कंक्रीट प्रोवाइड करना पड़ेगा. अगर आपका कंक्रीट 30 MPa के स्ट्रेंथ तक जाने वाला है कंप्रेशन के अंदर तो आपको कंप्रेशन में 30 MPa के हिसाब से प्रोवाइड करना पड़ेगा. ओके so accordingly you have to choose the materials. So if you want to avoid choosing such kind of materials and you want to limit the amount of stress we are going to use over here, तो आपको उसको permissible stresses के values को अगर कब में रखना है, so we use such kind of cable profile. Now this cable profile, when I say parabolic cable profile, इसका मतलब क्या है कि आपका जो loading है उस loading को ये match करता है. ठीक है. There is also another word for such kind of pre-stressing. Okay. Can anyone tell me that what is that word?
Load balancing.
You can either speak loudly or you can put it into the chat box. Now Hamza is asking me that how parabolic pre-stressing is done. Okay, so try to understand that in the pre-stressing part itself, जो आपका section है, ये section के अंदर पहले से ही एक होल जो कि पैराबोलिक है नेचर के अंदर, वो होल यहाँ पे इस होल को इस तरीके से पैराबोलिकली शेप के अंदर इसमें छोड़ दिया जाता है. ठीक है. और उस होल के थ्रू ये जो एम्प्टी होल होता है, ये होल का जो डाया होता है, दिस डाया इज अराउंड 50 mm. नाउ डिपेंडिंग ऑन द साइज, अलग अलग साइज, एक केबल जाने वाला है, 2 केबल जाने वाले हैं, 3-4 केबल का गुच्छा जाने वाला है. डिपेंडिंग ऑन दैट ये साइज बड़ा छोटा हो सकता है, 50 का 150 भी हो सकता है. ओके सो इस तरीके से ये होल रहते हैं. ये होल ये लोग कैसे किस तरीके से प्रोड्यूस करते हैं, ये ऐसा शेप का पाइप आता है पैराबोलिक शेप का. ठीक है. उसको हम लोग यहाँ पे इस तरीके से वहाँ पे प्रोड्यूस करते हैं और वो फिर उसके अराउंड कास्टिंग की जाती है. ठीक है. और वो कास्टिंग होने के बाद में वो पाइप को इधर रिमूव कर दिया जाता है या वो पाइप उसी जगह पे वहीं पे रहता है. ठीक है. उसकी पोजीशन को होल्ड कर इस तरीके से जो हमको जैसी चाहिए, जितनी इसेंट्रिसिटी चाहिए, जो भी चाहिए, उसके हिसाब से हम पहले से ही वहाँ पे वो पाइप डाल के होल को पहले से ही अटका लेते हैं और उसके बाद में हम लोग उसके अराउंड कास्टिंग करते हैं. ठीक है. इस तरीके से हमारा जो कंक्रीट का ब्लॉक होता है उसमें ऑलरेडी वो होल प्रोड्यूस होता है. अभी फॉर द प्री स्ट्रेसिंग स्टूडेंट्स दिस ईयर बिकॉज द साइट विजिट वाज नॉट पॉसिबल, यू वुड हैव प्रोबेबली नॉट सीन इट, बट जब हम लोग साइट विजिट वगैरह करते हैं या आपने कहीं पे अंडर कंस्ट्रक्शन जहाँ पे ब्रिजेस वगैरह का काम चल रहा हो, वहाँ पे बहुत सारे क्रॉस सेक्शंस अगर कभी आपने देखे होंगे तो ऐसे वो ट्रक के ऊपर क्रॉस सेक्शंस रख के लेके आते हैं. पूरे एक ट्रक के ऊपर एक क्रॉस सेक्शन होता है वो, जिसको हम लोग मच्छी के पेट के जैसा बोलते हैं. पूरा शेप रहता है, बीच में से हॉलो रहता है, कुछ वर्टिकल सेक्शंस रहते हैं और उस सेक्शंस में अगर आप ध्यान से देखेंगे तो होल्स होते हैं. ये जो होल्स होते हैं इसके अंदर से वो वायर्स को पिरोया जाता है. ओके एंड वी आर जस्ट टॉकिंग अबाउट वन केबल राइट नाउ, but at the time of actual pre-stressing in bridges, in heavy structures, there are multiple cables, multiple profiles. हर केबल अपने अपने प्रोफाइल पे है. कुछ केबल स्ट्रेट रहते हैं, कुछ केबल पैराबोलिक रहते हैं, कुछ अबव द न्यूट्रल एक्सिस रहते हैं, कुछ बिलो द न्यूट्रल एक्सिस रहते हैं. सबका अलग अलग काम होता है. ये सब का जो कंबाइंड इफेक्ट होता है, वो कंबाइंड इफेक्ट से फाइनली जाके वो जो अमाउंट ऑफ स्ट्रेसेस हमें न्यूट्रलाइज करने होते हैं वो न्यूट्रलाइज कर पाते हैं। और उसका मेन पर्पस ये होता है कि उसके अंदर का जो ब्रिज के बीच में जो हमको हॉलो डेक सेक्शन मिलता है, वो हॉलो डेक सेक्शन मिल जाए। आप बिना रिस्ट्रेसिंग के भी ब्रिज बना सकते हैं, लेकिन क्या होगा, आप इतना लंबे स्पैन का नहीं बना पाएंगे। और उसके अंदर जो आपका डेड लोड है, अगर आपने ब्रिज इंजीनियरिंग स्टडी करना चालू किया है तो आपको पता चलेगा कि ब्रिज इंजीनियरिंग में लाइव लोड बेंडिंग मोमेंट से ज़्यादा डेड लोड बेंडिंग मोमेंट होता है। जब आप ब्रिज डिजाइन करते हैं तो यू विल फाइंड आउट दैट dead load bending moment is more than live load bending moment, and that too we are considering in live load that a tank is going to pass. We are not considering our SUVs, or we are not considering our trucks or 6 axle trucks. We are not considering that. We are considering a full-fledged army tank that is passing over there, that is class A loading. इस तरीके का लोडिंग अगर हम लोग कंसिडर कर रहे हैं, ठीक है, सो फॉर दैट पर्पसेस आई एम सेइंग कि ये जो लोडिंग हम लोग यहाँ पे कंसिडर कर रहे हैं, इतने लोडिंग के लिए भी अगर हमने लाइव लोड लिया तो भी हमारा लाइव लोड बेंडिंग मोमेंट जो है वो कम आता है। आर यू गेटिंग इट? इतना डेड लोड ज़्यादा होता है। तो अगर आप क्रॉस सेक्शन बढ़ाने को सॉल्यूशन समझ रहे हैं कि अगर मैं क्रॉस सेक्शन बढ़ा दूंगा, मैं थोड़ा सा कंक्रीट या स्टील बढ़ा दूंगा तो कंक्रीट और स्टील बढ़ा देने से मेरा सेक्शन सेफ हो जाएगा, ऐसा नहीं होगा। उसका जो एक अपन बोल सकते हैं कि कंबाइंड इफेक्ट, आपने जैसे ही सेक्शन बढ़ाया उसके साथ में उसका डेड लोड और लाइव लोड भी बढ़ जाता है, ठीक है। उसका डेड लोड बढ़ जाएगा, डेड लोड बढ़ जाएगा तो उसका डेड लोड बेंडिंग मोमेंट बढ़ जाएगा। अगेन यू विल ट्राई टू इंक्रीज द क्रॉस सेक्शन, सो इट विल कीप ऑन प्रोग्रेसिंग इन अ लूप इटसेल्फ. So that's why we require some innovative methods to counteract that. Okay? Or otherwise you will be limited to a certain amount of span. कि भाई आप 15 मीटर या 20 मीटर का ब्रिज बना सकते हैं, जो ब्रिज आपके लिए एज पर आरसीसी सेफ रहेगा। लेकिन अगर आपको 100 मीटर और 200 मीटर के स्पैन के ब्रिजेस चाहिए, जो आप बॉम्बे के अंदर यूजुअली देखते हैं, जो फ्लाईओवर्स वगैरह बनाए हैं, जिसके अंदर एक पियर से लेकर दूसरे पियर तक का जो डिस्टेंस है वो 50 मीटर रहता है, 100 मीटर भी रहता है। इतने डिस्टेंसेस के अगर आपको पियर चाहिए, पियर टू पियर के डिस्टेंसेस चाहिए, so then you require to do pre-stressing. Okay? Now those cables that we try to provide which are similar to the bending moment diagram, ऐसी केबल प्रोफाइल जो कि बिल्कुल सेम हो आपके बेंडिंग मोमेंट डायग्राम से, ऐसी केबल प्रोफाइल या ऐसी प्री स्ट्रेसिंग को हम लोग बोलते हैं कॉन्कॉर्डेंट. कॉन्कॉर्डेंट. ओके, लेट मी जस्ट राइट इट फॉर यू on the screen. Such kind of cable profile concordant cable profile. Okay, now let us discuss some of the classifications of pre-stressed concrete systems. Okay, so pre-stressed concrete structures can be classified in a number of different ways we have already seen. Okay, so first type of pre-stressing or first type of differentiation is externally or internally pre-stressed. Okay, now externally pre-stressed, what do you mean by externally pre-stressed? Externally pre-stressed means pre-stressing cables not contained within the concrete cross section. ठीक है, so ऐसी प्री स्ट्रेसिंग, जिस प्री स्ट्रेसिंग के अंदर जो आपके केबल्स हैं वो कंक्रीट के अंदर नहीं है, केबल्स जो है वो कंक्रीट के बाहर हैं, फिर भी आपको प्री स्ट्रेसिंग इफेक्ट मिल रहा है, फिर भी आपको वहाँ पे अपोजिट स्ट्रेसेस या अपोजिट कंडीशंस का अनुभव होता है. ठीक है, सो दैट इज कॉल्ड योर एक्सटर्नली प्री स्ट्रेस्ड. Okay, so some of the times external pre-stressing is provided using jacks. Okay, some of the time external pre-stressing is provided using jacks, some of the times, and some of the times it is provided using cables in the cable stayed bridge. Have you seen a cable stayed bridge? There are bridges like this. अपना बॉम्बे में है केबल स्टेट ब्रिज, देखा है क्या किसी ने? Okay, in cable straight bridge, the cables which are used over here, these cables are stretched. Okay, these cables are stretched and then they are anchored with the bridge. Okay, that means the cables have initial tension in them, means the cable wants to pull the bridge upward itself. ऐसा नहीं है कि ब्रिज के लोड की वजह से उसने उसको पकड़ के रखा है। जो केबल्स हैं स्ट्रेस है, जो कि एक्चुअली कंक्रीट के अंदर नहीं है, वो एक्चुअली कंक्रीट के बाहर है, लेकिन क्योंकि उसमें पहले से वो स्ट्रेसेस इंड्यूस्ड हैं, वो ब्रिज को ऑलरेडी ऊपर की तरफ खींच के रखने की कोशिश कर रहा है। ठीक है, इट बाय इटसेल्फ विदाउट इवन द एक्टिंग ऑफ एनी सेल्फ वेट, विदाउट एनी एक्टिंग ऑफ एनी लाइव लोड, द cables which are already stressed cables are trying to pull or provide some extra reaction to that particular bridge, okay, which is in itself trying to keep the bridge in hogging position as in opposition to its natural position of sagging. Okay, so that way the external cables, or with the help of external cables, we can provide external pre-stressing. Okay, and with internal cables, you know that we have seen few of the problems also. That way we provide internal pre-stressing. ठीक है, जिसके अंदर केबल जो है वो कंक्रीट के अंदर से जाता है. Okay, then there is an example or there is a differentiation, क्योंकि हम differentiation की या different types के pre-stressing की बात कर रहे हैं. There is linear and circular pre-stressing. Okay, now circular pre-stressing is applied to circular structures such as pipes, silos and circular tanks. Okay, जैसे कि आपका एक पाइप है यहाँ पे, ठीक है, तो ये पाइप के अंदर यहाँ पे पाइप के अंदर उसके बाउंड्री के अंदर इस तरीके से स्पाइरली हम लोग प्री स्ट्रेसिंग केबल को प्रोवाइड करते हैं स्ट्रेच कंडीशन के अंदर. ओके, एंड दैट वे वी ट्राई टू प्रोवाइड प्री स्ट्रेसिंग. अगर इसको अगर आपको देखना है तो कई तरीके के टैंक्स होते हैं. हैव यू सीन टैंक्स, स्टोरेज टैंक्स, बड़े बड़े कंक्रीट के स्टोरेज टैंक्स रहते हैं. इसके अंदर भी सर्कुलर प्री स्ट्रेसिंग प्रोवाइड की जाती है. ठीक है, बड़े बड़े जो आपके स्टोरेज के जो टैंक्स रहते हैं ना, उसके अंदर साइलोज रहेंगे, टैंक्स रहेंगे. ठीक है, इफ द कर्वेचर इज नॉट सर्कुलर, ये देखो यहाँ पे समझने की बात है कि कब हम लोग बोलेंगे लीनियर और कब बोलेंगे हम लोग के सर्कुलर है. जब कर्वेचर बहुत छोटा हो, इतना छोटा हो कि वो घूम के वापस अपने सेम पोजीशन पे नहीं आने वाला है. ठीक है, बहुत ही कम कर्वेचर हो. सो इफ द कर्वेचर इज लेस, इट इज लीनियर. लीनियर मतलब इसके अंदर आप समझ सकते हैं कि वी आर टॉकिंग अबाउट पैराबोला एज वेल. ओके, पैराबोला, लीनियरली वेरिंग, ये सब आ गए इसके अंदर. पैराबोला, लीनियरली वेरिंग, ये सब लीनियर में आ गए. और सर्कुलर मतलब इतना ज़्यादा कर्वेचर है प्री स्ट्रेसिंग केबल का कि इट इज गोइंग टू ऑलमोस्ट लाइक लुक लाइक अ लूप. ओके, so that's why linear pre-stressing and circular pre-stressing. Then another type of variation is pre-tensioned and post-tensioned. Pre-tensioned post tension. So pre-tension and post-tension. So on the basis of sequence of concrete and steel operations, on the basis first कैसे पता चलेगा कि pre-tension है कि post-tension है? On the basis of sequence and steel operations. अगर आप कंक्रीट पहले कास्ट करते हैं, स्टील बाद में करते हैं, तो पोस्ट टेंशनिंग हो जाएगी. अगर आप स्टील को पहले टेंशन करते हैं और कंक्रीट बाद में कास्ट करते हैं, तो वो प्री टेंशनिंग हो जाएगा. ओके. Similarly, another statement is there: if steel is stressed before concrete, it is classified as pre-tensioning. ओके. सो ये सब चीज़ को बनाने के बहुत सारे इंटरेस्टिंग तरीके हैं, अलग अलग तरीके की चीज़ें हैं. जैसे फॉर एग्जांपल आपने रेलवे का ये देखा होगा, जो आपका स्लीपर होता है, रेलवे का स्लीपर, कंक्रीट का स्लीपर आता है. ठीक है. ये जो कंक्रीट के स्लीपर रहते हैं, ये स्लीपर को अगर आप ध्यान से देखेंगे, जो प्रीस्ट्रेस स्लीपर्स आपको मिलेंगे, तो इन दैट यू कैन फाइंड आउट that there are few small wires which are visible. Some of the times they are visible if the plaster or the cover over from that side has fallen off. You will easily be able to see those wires and cables which are provided over here. These are the pre-stressing cables. Okay. Now if you want to make these sleepers, they are usually made in a formation like this. Okay. एक साइड के ऊपर आपको ऐसा एंकर किया हुआ रहता है, जहाँ से वायर है, ये वायर पूरा इस तरीके से पास हो रहा है. मल्टीपल कंपोनेंट्स जो है, मल्टीपल स्लीपर्स जो हैं, वो इसके अराउंड इस तरीके से, ये यहाँ पे एक जैक लगा हुआ है और वो जैक के थ्रू यहाँ पे स्ट्रेच किया गया है. ठीक है. मल्टीपल कंपोनेंट्स जो है वो यहाँ पे इस तरीके से कास्ट किए जाते हैं, कॉन्क्रीटिंग की जाती है. ठीक है. उनका फोमवर्क वगैरह लगा के यहाँ पे कास्टिंग की जाती है. आपका पूरा कास्टिंग बेड है. ठीक है. अलग अलग एक साथ में एक ही वायर के अंदर मल्टीपल कंपोनेंट्स को रख के कास्टिंग की जाती है. और इसकी क्यूरिंग के लिए जो स्पेशल प्रोविजंस किए जाते हैं, ये जो ग्रेड ऑफ कंक्रीट यहाँ पे यूज़ किया जाता है, ये M75 रहता है. ठीक है. एंड एक पूरा इस तरीके से एक ऐसा ब्लैंकेट इसके ऊपर डाल दिया जाता है और यहाँ पे उसको स्टीम क्यूरिंग की जाती है. एक पूरा ब्लैंकेट के अंदर डाल के ये पूरा इसके अंदर जो है वो स्टीम क्यूरिंग की जाती है. तो स्टीम क्यूरिंग करके उसका जो डिजायर्ड स्ट्रेंथ है, डिजायर्ड कॉम्पैक्शन है, डिजायर्ड जब हम लोग को उसकी मिल जाती है, उसके बाद में हम लोग क्या करते हैं कि जब ये पूरा स्ट्रेंथ गेन कर लेता है, सब कर लेते हैं हम लोग, एंड वी स्टार्ट कटिंग द केबल्स. ओके. क्योंकि कंक्रीट ऑलरेडी जो है उसका स्ट्रेंथ गेन कर चुका है. जैसे ही हम लोग केबल को कट करते हैं, तो केबल का जो लोड है वो उसके अंदर ट्रांसफर हो जाता है. प्री स्ट्रेस जो है वो उसके अंदर ट्रांसफर हो जाता है. इसका जो कंडीशंस है जिसके अंदर इसको हमें क्यूरिंग की जाती है, इट इज फुल्ली सैचुरेटेड एट 100 डिग्री सेंटीग्रेड. fully saturated at 100 डिग्री सेंटीग्रेड. ओके. यूजुअली रेलवे लाइन कंस्ट्रक्शंस के अंदर जो हम लोग स्लीपर्स देखते हैं, ये प्री स्ट्रेस कंक्रीट के अंदर सबसे ज़्यादा बनाए जाने वाले कंपोनेंट्स हैं. ओके. इज इट क्लियर अप टू दिस स्टेज? ओके. सो दिस इज वन लेक्चर दैट वी हैव डिस्कस्ड राइट नाउ. In the next session, we will discuss another part. Okay. If there is any doubt or any query regarding anything, please do ask me. Anyone has any query regarding this particular topic that we discussed today? Today we understood the analysis of pre-stress, as well as we understood a little bit theory about differentiation and different types of pre-stressing, as well as we also discussed the previous part that we had already covered. Okay, is it clear up to this point?
Yes, sir.
Okay, so thank you everyone for patiently listening to this session, and we'll see you again. There is one lecture that we are lagging behind, so probably in coming 1 or 2 days, I'm feeling much better. So I'm going to have one more lecture of this. Okay. So as and when your time is free, I will inform you in the group when we are going to conduct another lecture. Okay. Thank you, everyone.
Thank you, sir.